Hello Advanced Mathematics. Today we're going to be doing 7.1 of your textbook, which is about linear functions. And the first part of this linear functions topic is all talking about distance. Okay, so we need to know how far it is from different points. Now when we're talking about linear functions, we're having a look at our lovely Cartesian plane. You know, the one where we have x and y, a zero in the middle, and we're talking about different coordinates on this Cartesian plane. So here we might have x equals 1, y equals 2, and this would be the point 1, 2. We always do the x point first and the y point second. Okay, now in this one we're going to be looking at how far it is from different points. So here we've got our first point, and then perhaps our second point is down here at y equals 2 and x equals 1. Well, this is minus 2, so 1 minus 2. So we want to know how far away these 2 points are, okay? This is what we want to know, the distance here. So this point, obviously, we've got 1, 2, 3, 4 away. That's easy, we can just count it because this here is on the same x value. We could do the same thing if we had a different y value. So let's go x equals 3, y equals 1, so that would be 3, 1, and over here we've got x equals minus 2, y equals 1. So here we go, minus 2, 1. Now in this case we go 1, 2, 3 points to get to there, and then another 2 to get to there. So that one's going to be 5 points away. Okay, that's because they're in the same line, so we're just counting the units of the line, how many units. However, what happens if we get 2 points that are not on the same line? They're going to be on a diagonal line. Perhaps we get something like x equals 1, 2, 3, y equals 1, 2, and then a second point, maybe x equals minus 1, 2, 3, 4, y equals minus 1. In that case, we're going to have a diagonal line connecting these two together. Now, how do we find out what the distance of this diagonal line is? I wonder. So, if you want to know what that diagonal line is, we've got to draw ourselves a triangle. So here we go. Triangle here, and there's our two lines of the triangle. We could easily work out what this side is and what this side is. Look, this side goes from 2 down to minus 1, so it's going to be 3 units. This side goes from 3 to minus 4. 1, 2, 3, 4, 5, 6, 7. That one's going to be 7 units. So the distance of that, we're just going to be able to use Pythagoras' theorem. Ooh! With an incorrect spelling of Pythagoras there. Pythagoras, which gives us a squared plus b squared equals c squared. Here's our a, 3 squared plus 7 squared equals c squared. So 9 plus 49 equals c squared. So 58 equals c squared. C equals the square root of 58. That doesn't really work out very nicely for us, but you can see that's the distance there. We could plug that into our calculator, the square root of 58. So you can easily see how we'd be able to find the distance the distance here. Now we can learn our distance formula, which is very, very similar to what we've just done there. It's just a simpler way of writing it. So our distance formula is going to be the distance between 2 points. Here we go, d is distance between 2 points is going to equal the square root, remember this relates to this square root over here, so a big square root of an x value, we call the first x value x2, another x value, x1, squared. Just like over here, how we got to that 3 there. Okay, and then we're going to add y value 2. Make sure these two link up. You could do this value, this is the first value, this is the first value, this is the second value, this is the second value. As long as this one corresponds. y2 minus y1 squared. Okay? So that will give us our distance. So if we had a look over here, we would do the same thing. It would be x1 will go 4, so we go, in the case of the other one, minus 4 minus 3 squared plus minus 1 minus 2 squared. Now I don't know why I put a minus on that 3, that's actually a plus there. Okay, so we finally get minus 7 squared, which of course is 49, plus minus 3 squared, which of course is 9, which gives us our final answer of root 58. Okay? So that is how to use the distance formula to be able to find the distance between any 2 points, 7.1 linear functions.